Welcome to IOQM 2023 paper, part 3 of the video. So in this one, we will look at 16 to 20 questions, all are 3 marks questions. Okay, let's start. So question is, let's look at the diagram and understand. The 6 sides of convex hexagon A1, A1 to A6 are colored in red. Okay, each of the diagonals of the hexagon are colored either red or blue. Okay, these are all the diagonals I drawn. There are 2 types of diagonals. One is exactly opposite diagonals, which are in green, and the other diagonals which are in blue color. Okay, these diagonals are colored in either red or blue. Okay, if n is the number of colorings such that every triangle AI, AJ, AK, where AIJK are between 1 and 6, means you take any 3 sides with this, okay, and form a triangle. Okay, then the number of colorings that is required, which will have at least one red side. Okay, of the 3 sides, at least one should be red color. Find the sum of squares of the digits of n. Okay, yeah, so let's see how to do this. Number of diagonals uh, in hexagon is 62 minus 6, which is equal to 9. So we have drawn all the 9 diagonals here. Okay, number of ways to color A1, A4, A2, A5, A3, A6, A1, A4. Okay, these are the basically opposite diagonals, exactly opposite diagonals, which are in green color shown here. Okay, so if you see these diagonals uh, require at least one side, one edge to form a triangle, correct? You cannot form a triangle with these diagonals and any other diagonal. Okay, you cannot form a triangle. So it requires at least one edge, and edge is already colored in red. Okay, so you will get the at least one red color condition is satisfied. So these green diagonals, 3 of the green diagonals can have any color, right? So that is 2 power 3, which is equal to 8. Okay, 2 colors each in the 3 diagonals. So 2 into 2 into 2, which is 8. Okay, now next is second set of diagonals, which is A2, A4, A6. If you see A2, A4, A6 formed by these are A1, A3, A5. Okay, let's look at A2, A4, A6. Okay, so this one requires any color. Okay, only one exception is all 3 cannot be blue, so -1 I am doing. Okay, so 2 power 3 minus 1, which is 7 colors possible here. Okay, similarly A1, A3, A5. Okay, the other blue triangle. Okay, so 7 colors possible here. Total number of colors possible are 8 into 7 into 7, which is 392. This is what is n is. Okay, now we need to find out sum of squares of digits of n. So the answer is 3 square plus 9 square plus 2 square, which is equal to 94. Okay, yeah, this is moderate. You need to understand from the hexagon and the diagonals which one are can be colored in any color and which can be colored with minimum one red, all those. It's a moderate. Next, consider set S equal to ABCDE. Okay, ABCD are between 0 and 100 and in the increasing order. Okay, and the D is the average value of the fourth element of such a tuple. Okay, in the set taken over all the elements of S. Okay, find the largest integer less than or equal to D. Okay, so he's trying to write numbers A, B, C, D, E, so where we have to take is with the condition that each one they're in the incremental order, basically integer values are the digit values are. So you need to take the average of D over all elements of S. Okay, so let's see how to do it. So we know that D value will be between 4 and 98 inclusive, because it cannot be less than 4, because 1, 2, 3 has to be this other 3 smaller digits has to be 1, 2, 3. So 4 is the minimum value and 98 is the maximum value. It cannot be 99 because E has to be 99. right? If it is 99, then E cannot be 100. That's not possible. Right? So this is the first condition we'll derive. And then if D equal to 4, possibilities are, okay, if D equal to 4, A, B, C are 1, 2, 3, obviously, there is no other option. So 3C3 into, okay, E can be anything from 5 to 99, correct? So you have how many options? 99 minus 5 plus 1, C1. So many options are there, okay? So these many options are there with D equal to 4. And the sum of the terms will be these numbers, so many numbers into 4. So many times 4 will be there, right? So this is the one, okay? Now, if D equal to 5, what are the possibilities? ABC can be any of the 4 numbers, right? 1, 2, 3, 4. So 4C3. And E can be 99 minus 6 plus 1, okay? C1. So sum of terms is 5 times 4C3 into 94C1. So it will go like this, okay? And when D equal to 98, possibilities are 97C3 into 99 minus 99 plus 1, that is 1C1. Okay, so sum of terms will be 98 into 97C3 into 1C1. So, so this is the uh, sum of D terms. Okay, possible elements are all this basically. Okay, so this is sigma of R equal to 1 to 95, 99 minus R into R, 99 minus R, C3. Okay, so if I multiply with 4 and divide with 4, this is what it will be 99 minus R by 4 into R, 99 minus R, C3. So I can combine 99 minus R, C3 and 99 minus R by 4 to make it 99 minus R, C4. Okay, so the value will be sigma, okay, R equal to 4 times sigma R equal to 1 to 95, R 99 minus R, C4. This is the value. Okay. Mm. Okay, you should know this formula, okay, which shows sigma R equal to 1 to 95 R times 99 minus R C4 equal to 100 C6. Okay, so once you know this, you can replace it. Okay, so that is 99 C5 is the total possibilities, and this is 4 times 100 C6. So your average value is 4 times 100 C6 by 99 C5. Okay. So just simplify it and multiply. What you will get is 200 by 3. Okay, so 200 by 3 closest integer is 66. This is the value answer. Yeah, this is definitely harder. Next, let P be a convex polygon with 50 vertices. Let's understand with the diagram. Okay, example diagram this is. A set F of diagonals of P is said to be minimally friendly if any diagonal D belongs to F intersects at most one other diagonal in F. At most means either it can intersect other diagonal or don't intersect. That's it. But only maximum it can intersect one diagonal. Okay. At a point interior to P. Find the largest possible number of elements in a minimally friendly set F. Okay. So let's understand with the example of the diagram here. Let's take a polygon with 12 sides. Okay. So A1 to A12 are there. Okay. How many diagonals we can draw from one point? Okay. So that is basically 12 minus 3. What is this minus 3? A1, A2, A12 cannot be included. If you take all diagonals you are drawing from A1, then A2 and A12 cannot be part of this, right? So minus 3. Okay, so many number of diagonals you can draw. That is n minus 3. Okay, in this case, 12-sided edged polygon, it is 9. Okay. Now you can also draw A2, A4, A4, A6 like that. Okay, so A2, A4, this will intersect only diagonal only once. Okay, and A4, A6 only once. Okay, but if you take, let's say, A1, A3, okay, sorry, yeah, A2, A5, any other diagonal you take basically, okay, A1, A4, any other diagonal you take, it will intersect other diagonals more than once. So only possible things is either from one given point you draw the diagonal, and only this A2, A4, A4, A6, this is the only possible combination. Okay. So how many diagonals you can draw? Basically 5, that is 12 minus 2 by 2, which is n minus 2 by 2. Okay. So just use the general. So total diagonals for n-sided polygon with the minimal friendly uh, condition is n minus 3 plus n minus 2 by 2. Okay. So for a 50-sided polygon, the answer is 50 minus 3 plus 50 minus 2 by 2, which is equal to 71 is the answer. I think this looks easy. Only thing is you need to understand question correctly. Okay. Next. N for n belongs to natural numbers. Let P of n denotes the product of digits in n, and S of n denotes S of n denotes the sum of digits in n. Okay. Consider set A, okay, where n belongs to n, P of n is non-zero, square free, and S of n is proper divisor of P of n. Okay. Find the maximum possible digits of the numbers in A. Okay. So to understand the question, basically n is formed from digits A, B, C, D, E, F. Okay, these are all digits. Okay, and he's telling they are square free. That means you cannot have a 4, you cannot have 9. You cannot have basically products. Basically, 6 also is not possible. Okay, because once you take 6, it is 6 is a product of 2 into 3. So 2 and 3 are already part of it. So you cannot take 2 comma 3 and 6 together, right? It will become squares. So now you cannot repeat 2, 3, 5, 7, because if you repeat, they will become again squares. Okay. Now, what is the number you can form? Is obviously this number 2, 3, 5, 7 and all ones. Okay. This is the only possible things, because in this way there is no squares formed actually. This is a possible number. And if you take product of these numbers is 2 into 3 into 5 into 7 into 1, which is 210. Okay. And he is asking a S of n is a proper divisor of P of n. Correct? So what is the proper divisor? What is the maximum possible proper divisor of this number 210? 105, right? 105. So S of n has to be 105 at, at the max. Okay. So if S of n is 105, that means sum of digits of that number is 2 plus 3 plus 5 plus 7 plus some number of x number of ones, which is equal to 105. So if you simplify, you will get x as 88. So the number formed is digits for that one is 2, 3, 5, 7 and 111, 88 times basically. This is the number formed. Okay. So that means 88 number of digits of 1. So total number of digits are 88 plus 4. Okay, 2, 3, 5, 7, which is 92 digits are possible. The maximum possible number. Okay. So this is also, once you understand the question correctly, it's easy. Okay. Understanding question is very important. Next. For any finite non-empty set x of integers, let max of x denote the largest element of x and absolute x denote the number of elements in x. If n is the number of ordered pairs a comma b of finite non-empty sets of positive integers, such that max a into absolute b equal to 12 and absolute a into max b equal to 11. And n can be written as 100a plus. Let's find out first n and then we can understand this. This is very simple. Okay. So first understand the question. There are two cases, right? We will try to solve it from Case 1 is where absolute A into max of B equal to 11. Okay, let's take this one. This is the case 1. Okay, so that means absolute A equal to 1 and max of B equal to 11. This is what I want to take. Okay, now max of A equal to into absolute B equal to 12. This is the second condition to be satisfied, correct? So this will have several possibilities like 12 is a uh, 12 is not a prime number, right? So you will have 12 into 1, 6 into 2, 4 into 3, 3 into 4, 2 into 6. All possibilities are possible here, right? So let's take one by one. Uh, so 12, I'm writing it as 12 into 1. That means A equal to 12 because max of A equal to 12 and absolute A equal to 1. That means only one element is there, right? So only 12 has to be here. And then max of B equal to 11 and absolute B equal to 1, right? So which means B has to be 11. So how many possibilities I have? One, that is only one possibility is there. I am writing it as 10C 0. Okay. Second possible case for this max A into absolute B equal to 12 is 6 into 2. Okay. So max A equal to 6. Okay. Since A is only one element is there, 6 is the answer set here. But for B, basically you should have two elements, right? Two elements are possible. So that means A1 and 11 because max of B is 11 if you see here, right? So how many A1s are possible? A1 can be any of the number which is from 1 to 10, correct? So 10C1 out of 10 numbers, only one number is possible. So 10C1 is possible. Similarly, if max of A into absolute B equal to 4 into 3, then max of A equal to 4, that means A equal to set 4. Okay, only one element 4, but B has three elements, that is A1, A2 and 11, right? So possibilities are 10C2 possibilities are there because A1, A2 can be any of the 10 and only two values I am taking. So 10C2. Okay. If it is max of A into absolute B equal to 3 into 4, the possibilities are A is set 3 and B has four elements in total. One is 11 and other three can be formed in 10C3 ways. Okay. Similarly, for 2 into 6, A is set 2 and B is total 6 elements. Out of that, 5 are any number from 1 to 10. So 10C5 numbers are possible. So total number in the case 1 is 10C0 plus 10C1, 10C2, 10C3 and 10C5. Okay, now let's see the case 2. Case 2 is absolute A equal to 11. Okay, here I took absolute A as 1. So I'm changing basically the 11. I'm writing instead of 11 into 1, I'm writing 1 into 11 basically. So absolute A is 11 and the max of B equal to 1. So in this case, okay, A has 11 elements, correct? A has 11 elements and from the second max A into absolute B equal to 12, right? So from that it is very easy to guess, okay, that maximum is max of A is 12, correct? So these two 10 numbers can be written in 11C 10 ways, total number of ways, and B is only 1, okay? So total number of ways altogether from the both the cases is uh, all this sum and 11C10 plus 11C10. So the answer is around 439. The total is 439 can be written as 100 into 4 plus 39, which is 100A plus B. Okay. So A is 4, B is 39. So A plus B equal to 43. This is the answer. I think this is definitely hard. Okay, moderate to hard, yeah. So if I see this IOQM 2023 paper, I think the second part of 3 marks questions, that is 16 to 20, are really you require a lot of knowledge and they are tough actually. So I think let's see how the 5 marks questions will be um, from the in the next videos, coming up video. Thank you.